Good afternoon, everyone. It's Francis. Getting a live feed from TV, Canarias, La Palma, Cumbre Vieja. The volcano on the Canary Islands has been erupting fantastically. It's not the only one, but this one is still very important to the geography of the world. Known research on this volcano has shown discontinuities in the land structure surrounding the fissures, discontinuities in my field, which is welding, carbon steel, stainless, discontinuities, signals of locations that are susceptible for cracking and after damage. Quality control does not want to see any discontinuities or indications of discontinuities in any of the welds. And if you looked at a weld and compared it to the host rock of the volcano, discontinuities is a signal that there are cracks in the underlying bedrocks. Still erupting fantastically. What a sight. Many homes have been damaged. The lava has reached the ocean. More vents and fissures have opened. There's no details of this eruption slowing down. New reports have come out that the volcano is creating gravity waves on its own. There are waves of gravity as it belches and erupts. You can see down here. It's supposed to be more than just a couple. There's supposed to be other areas of venting and fissures that have opened up. Alright, but what else is on the news? What else is on the news? A very large comet is entering into our solar system. We're going to find that this is very interesting and unique because some have foretold the arrival of an object whence to be noticed as a comet. This object, let's see what we have. We're over here at wwitv.com. wwitv.com gives you the live stream TV Canaria. Comet Bernardinelli-Berstein. One of the largest comets detected. It was first detected in 2014, but now we are witnessing it coming into one of its close approaches to the sun. Be very in the news, I'm sure, especially if it begins to warm up and begin to outgas. This is a very large comet. I don't want to say the miles quite yet. I don't know if it's 60 kilometers. Let's see. Giant comet found in outer solar system by Dark Energy Survey. A giant A giant comet from the outskirts of our solar system has been discovered in 6 years of data from the Dark Energy Survey. Comet Bernardinelli-Berstein is estimated to be about 1,000 times more massive than a typical comet, making it arguably the largest comet discovered in modern times. It has an extremely elongated orbit, journeying inward from the distant Oort cloud over millions of years. It is the most distant comet to be discovered on its incoming path, giving us years to watch it evolve as it approaches the sun, though it's not predicted to become a naked eye spectacle. A giant comet has been discovered by 2 astronomers following a comprehensive search of data from Dark Energy Survey DES. The comet, which is estimated to be 100 to 200 kilometers across, or about 10 times the diameter of most comets, is an icy relic flung out of the solar system by the migrating giant planets in the early history of the solar system. This comet is quite unlikely any other seen before, and the huge size estimate is based on how much sunlight it reflects. Pedro Bernardinelli and Gary Bernstein of the University of Pennsylvania found the comet, named Comet Bernardinelli-Berstein with the designation C2014 UN271, hidden among data collected by 570 megapixel dark energy camera deck cam mounted on the Victor M. Blanco 4-meter telescope at Cerro Tololo Inter-American Observatory, CTIO, in Chile. The analysis of from that Dark Energy Survey is supported by the Department of Energy, DOE, and the National Science Foundation, NSF, and the DECCAM Science Archive is curated by the Community Science and Data Center, CSDC, at the NSF's NOR Lab. CTIO and CSDC are programs of the NOR Lab. One of the highest performance wide-field CCD imagers in the world, DECCAM was designed specifically for the DES and operated by the DOE and the NSF between 2013 and 2019. DECCAM was funded by the DOE and was built and tested by DOE's Fermilab. At present, DECCAM is used for programs covering a huge range of science. DES was tasked with mapping 300 million galaxies across a 5,000 square degree area of the night sky, but during its 6 years of observations, it's also observed many comets and trans-Newtonian objects passing through the surveyed field. A trans-Newtonian object, or TNO, is an icy body that resides in our outer solar system beyond the orbit of Neptune. Bernardinelli and Bernstein used 15 to 20 million CPU hours at the National Center for Supercomputing Applications in Fermilab, employing sophisticated identification and tracking algorithms to identify over 800 individual TNOs from among the more than 16 billion individual sources detected in 80,000 exposures taken as part of the DES. 32 of those detections belong to one object in particular, C2014 UN271. Comets are icy bodies that evaporate as they approach the warmth of the sun, growing their coma and tails. The DES images of the object in 2014 to 2018 did not show a typical comet tail, but within a day of the announcement of its discovery via the Minor Planet Center, astronomers using the Los Cumbres Observatory Network took fresh images of Comet Bernardinelli-Berstein, which revealed that it had grown a coma in the past 3 years, making it officially a comet. Its current inward journey began at a distance of over 40,000 astronomical units from the Sun. In other words, 40,000 times farther from the Sun than the Earth is, or 6 trillion kilometers away, 3.7 trillion miles, or 0.6 light years, 1/7 of the distance to the nearest star. For comparison, Pluto is 39 AU from the Sun on average. This means that the comet Bernardinelli-Berstein originated in the Oort cloud of objects ejected during early history of the solar system. It could be the largest member of the Oort cloud ever detected, and it is the first comet on an incoming path to be detected so far away. Comet Bernardinelli-Berstein is currently much closer to the Sun. It was first seen by DES in 2014 at a distance of 29 AU, 4 billion kilometers, or 2.5 billion miles, roughly the distance of Neptune, and as of June 2021, it was 20 AU, 3 billion kilometers, or 1.8 billion miles, the distance of Uranus from the Sun, and currently shines at a magnitude 20. The comet's orbit is perpendicular to the plane of the solar system, and it will reach its closest point to the Sun, known as perihelion, in 2031, when it will be around 11 AU away, a bit more than Saturn's distance from the Sun, but it will get no closer. Despite the comet's size, it is currently predicted that skywatchers will require a large amateur telescope to see it, even at its brightest. We have the privilege of having discovered perhaps the largest comet ever seen, or at least larger than any well-studied one, and caught it early enough to people to watch it evolve as it approaches and warms up, said Gary Bernstein. It has not visited the solar system in more than 3 million years. Comet Bernardinelli-Berstein will be followed intensively by the astronomical community, including with NOR Lab's facilities, to understand the composition and origin of the massive relic from the birth of our own planet. Astronomers suspect there may be more undiscovered comets of this size waiting in the Oort cloud far beyond Pluto and the Kuiper Belt. These giant comets are thought to have been scattered to the far reaches of the solar system by the migration of Jupiter, Saturn, Uranus, and Neptune early in their history. This is a much-needed anchor on the unknown population of the large objects in the Oort cloud and their connection with early migration of the ice gas giants soon after the solar system was formed, says the NOR Lab astronomer Todd Lauer. These observations demonstrate the value of long-duration survey observations on national facilities like the Blanco Telescope, says Chris Davis, National Science Foundation Project Program Director for the NOR Lab. Finding huge objects like the comet Bernardinelli-Berstein is crucial to our understanding of the early history of our solar system. It is not yet known how active and bright it will become when it reaches perihelion. However, Bernardinelli says the Vera C. Rubin Observatory, a future program of NOR Lab, will continuously measure comet Bernardinelli-Berstein all the way to its perihelion in 2031, and probably find many, many others like it, allowing astronomers to characterize objects from the Oort cloud in much greater detail. This research was reported to the Minor Planet Center. The one thing I worried about is they might have spoke about La Palma, an observatory on La Palma. Let me just sit back real quick. A distance of Comet Bernardinelli is currently much closer. Current journey. Comets are icy bodies. Tracking algorithms being taken. And Chile. Okay, Chile is not that. Okay, so we have an announcement of Comet Bernardinelli-Berstein, one of the largest comets ever discovered. What were they talking? 100 kilometers? 100 kilometers in size. Coming in from the Oort cloud on a multi 10,000 year cycle. We have it not going to be coming in closer than Saturn, but right now it's out in the Uranus area. Over the last 4 years, they've been able to turn it on, to determine through observations that it was a comet, because over the past 4 years they have detected changes in its appearance and it producing a coma even so far out. It's going to be interesting as it comes in. They do state that it's probably not going to be a naked eye sight, even at its closest. They say that its closest approach again is quite a ways away, outside of Saturn. But this comet is going to be tied to some discussions about planet Nibiru, the 10th planet, and things like that. I just have that feeling. And so with that, we went out today being Australia's tomorrow. We went out today and took some pictures from Australia of the place where Comet Bernardinelli-Berstein is located. We used, let's see, We use T17. T17 is what we use today to produce 3 images. And so each image was 5 minutes, so the total imaging time was 15 minutes. So to tell you that we can see anything moving in these images, we can't. But I'm going to have to arrange an opportunity to come back and image this object again, or I'll just take an image of this area again, which is probably what I'll do. Using the data on the FITS file will tell me where this location is. This is actually 3 images blinking. I believe that's Comet Bernardinelli-Berstein. That should be, because it's just right about in the center of the picture. It has a fuzziness to it. It's not a star. It doesn't have a sharp edge. I'm looking around. There may be some other things. I don't believe it's a galaxy. There are some other fuzzy objects in the area, but if I was to guess it, this is going to be our object. And tomorrow I will come back and take a picture of this area again, so that we can see if there's anything moved from this area. And then I'll also take a picture tomorrow of the comet, and to see if they take me to another location, and it looks like this. So we are taking pictures. We're going to have them. What else do we have? I don't know, my feelings on La Palma are still not, I don't feel comfortable. Let me, something humanity hasn't seen. And we've seen a sample of it with Mount St. Helens, but we have not seen anything like what this thing could do. It's always already showing itself off to be unrelenting, day and day and day. If it just keeps creating, I mean, I don't know if it can create a top to itself, and then it's going to find a new exit. See, what else do we have? Anything else? We did that. My watch, eye telescope T17. That's what we use the daytime for our pictures of Comet Bernardinelli-Berstein. Got to confirm that. Have to confirm that. If you're watching this video and you've gotten this far, please subscribe and like the video. Please subscribe and like the video. Oh, I had something else. Here we have it. We can go full screen. And this is the orbit of Bernardinelli-Berstein, starting today. June 2022. January 2023. January 2024. January 2025. It's inside of Uranus. Shit. Sorry. 2026. And this thing's 2027. I tell you, I'm going to give you a heads up right now. This thing is going to be a godsend to all those who believe that there is something coming in 2029, because by this time it's probably going to be showing. But see, here's the thing though. Okay, this is the thing. This is a long-term event. This isn't going to happen in a year. But this is going to rewrite the books of the timelines to coincide with this 3031, January 3032, probably its closest approach to the sun. It's going to be in the sky for a long, long time. So I got me some pictures. We'll see what happens from there. Okay, so what else we got? That's a Bernardinelli-Berstein's path, orbital path, entering and exiting the inner solar system. Right now, its location on September 2036, passing Uranus's orbit once again, 2037. Alright, I think that's all. We go back here. This is just these are amazing shots. I hope everyone's doing well. Lots to pay attention to, lots to look at. Weather's been definitely cloudy lately here. We're going to have another night at the observatory very soon. We're going to have a star show pretty soon too. So this nicer weather, more opportunities to do some outreach and connecting with astronomy is coming up. Pray for the people in La Palma. Pray for everyone that might and may be affected if this were to get tragic on a grand scale.